Got it. Let me share my screen. Start the broadcast. And we are going to start here. Okay. All right, scholars. So welcome. Okay, you have to bear with me. I'm exhausted. I know I'm always exhausted when I get to you guys. It's just tough, you know. It's after lunch. I've been talking since like 9 this morning. So, and I got one more class after you go late this afternoon, but I can get a break. Let me see. So we are at the end of week 3, right? So what that means is that you can anticipate exam 1 to become available this upcoming Sunday at 11:11 a.m. And you can earn up to 100% for the first 7 days. Past the due date, then any question submitted past the due date, there's a 10% late penalty. Also an update about my math lab. So a student in the previous course asked, okay, has there been any update about the price reduction, right? So I reached out to my supervisor during class, and his response was, I think they're just gonna give you all another 14-day extension. So there should be an email about it. You know, so if your 14-day trial is running out, you should get another 14-day trial while they still trying to negotiate this thing. It was supposed to be resolved before the semester started, but that's just not what happened. So, you know, you should either check your email for, of course, for an update on that, or reach out to like the math office or the bookstore. I think one of those two sources should have information on this. But again, right now you should get an additional 14-day trial. Well, that gives them more time to like, you know, negotiate this discount or whatever. Let me see. Let me hop over to Zoom real quick, see if I got some stragglers. I do. Let them in. Okay. All right. So with exam 1 becoming available this Sunday, also, I think Monday's a holiday. It's like Labor Day, so we're not going to meet on Monday. So just, you know, enjoy your weekend, enjoy your holiday. I mean, we're meeting right now. I hate to say it that way, but we are meeting right now. But yeah, Monday is going to be a holiday, so there's no school that day. So after today, we're going to meet again next Wednesday. All right. So those weeks are always nice. So because on Monday, this past Monday, you know, we didn't really get to talk about 1.3 together, but you're still responsible for it. Remember, all of my lectures are already pre-recorded and they're available for the entire semester, right? They've been available since the beginning. Basically, last semester, I took some time and I you know, made dedicated lectures for each section. So anything that I'm going to say live that's of importance is already in the pre-recorded lectures, right? So you don't have to wait for me. I'm just doing these things live, just kind of like just to be live and for us to kind of go back and forth. But, you know, as far as the meat and potatoes, you already have access to it. It's really just sitting there waiting on you. So today what we're going to do, what I would like to do is go through as many homework questions in review, preparing for exam 1, right? So those are questions from sections 1.1, 1.2, and 1.3. And we're going to actually start with section 1.3. So I'm going to hop over to my math lab. I'll check that later. I'll go back to my courses. So this is College Algebra 1. Also, hopefully you all have been, is that the right one? That's not the right one. That's not right. We'll go back. Hopefully you all have also connected with Dr. Lamar concerning the lab, right? Remember, she manages the lab. The lab is a completely separate component. And basically what's going to happen is that she's going to give me a grade for each student at the midterm and at the final. And then I'm going to take that grade and scale it to 10% of your overall grade, right? So if you want to maximize that, just, you have to connect with Dr. Lamar. She facilitates the lab and follow her instructions. Okay, so we're going to open up to 4 p.m. Check Zoom one more time. Yeah, I think you guys look good. Okay. Come on. Right here. So, and let me hop over to Zoom here. I don't want to switch. I'm hesitant to clicking on that. I'm just going to join. It is correct. It's crazy. I just gotta, anyway, I'm gonna leave that be. Don't turn my video off and I'm just gonna, okay, join. I stay as a participant. Okay, so let's start with let's start with section 1.3. Okay. And let's see. Ooh. Hey, Google, give me a random number between 1 and 21. Let's try this again. Hey, Google, give me a random number between 1 and 21.
Here's a random number, 4.
4. Okay. Let's look at 4. This one says, determine whether the equation defines y as a function of x, right? So we have this. For something like this, you can solve for y here. If we were to solve for y, can anybody explain to me, how do we get rid of that squared on top of the y? How do we get rid of that? Well, in other words, what's the inverse operation of squared, right? Take a moment. The inverse operation of squared is going to be what? Square root, right? So if we were going to solve for y and we take the square root on both sides, whenever we introduce the square root symbol, what other symbol do we also need to incorporate? So the other symbol that we also need to incorporate is going to be plus or minus. Whenever we take the square root or any kind of even root, like fourth root or sixth root or anything like that, we have to introduce the plus or minus symbol based on the context, right? So if we introduce the plus or minus symbol, do you think that this is going to, does this equation define y as a function of x? Yes or no? So let's use the reactions in Zoom, right? If you feel like yes, this equation defines y as a function of x, then we're going to do thumbs up. But if you feel like it's no, let's do the laughing emoji, the LOL emoji, right? So if you feel like yes, this equation does define y as a function of x, let's do thumbs up. And if you feel like it's no, let's do laughing emoji. Let me see the participants. Okay. Are you guys there? Are you alive? Hopefully you guys are alive. Okay, I see one thumbs up. So that's one yes. Any other yes? Anybody else for yes? I see a second one. Okay. Yeah, I feel, wait a minute. All right. Okay, remember we had the plus or minus, right? So what that means is like we could find, like for instance, when x is 0, right? When x is 0, what's going to be our corresponding y? When x is 0, we're going to get plus or minus the square root of 7. We get 2 values of y corresponding to 1 value of x. So that's an example of something that fails the vertical line test, all right? So this should be a case of something that fails the vertical line test. So therefore the equation does not. So it should have been the laughing emoji, all right? So that's okay. Let's try that again. Right? So that was good. Suppose we're working on our own and we just had no clue. Obviously, we can guess. We got a 50-50 chance of being correct if we just guess. But chance favors the prepared mind. If you want to boost the odds of success in your favor, guess I forget how he used to say that. But long story short, chance favors the prepared mind, right? Okay, practice, right? So we could click on the get more help, right? My recommendation is the view an example. I know one student earlier said that he liked to use to help me solve this because he liked the way that it breaks down the equation. So, just try these different learning aids to see which one you like. But I personally like to view an example because basically what it does, it gives an explanation for each question. Like nearly all of the homework questions have the view an example. And so it's going to be a question, the exact same questions with different numbers. So a similar question. And it gives you a detailed explanation. So all parts are showing, all right? And so you can kind of go through that to get an explanation. All right, yeah, I definitely need to take a nap. Okay, so we're gonna let that be for now. And let's choose a different question. Which question do you think Google is gonna choose for us, all right? Between 1 and 21. If you had to guess, I'm gonna guess, I'm feeling 9, all right? Let me see the chat real quick. What number do you think Google is going to choose for us, if you had to guess? Let's see. Morehouse? Invites, applications, winter time, spring break. Yeah, I want to do that. I want to do it. I need to just submit it. I got to take some time to do that. Okay, so let's see. I'm going to guess 13 this time. Hey, Google, give me a random number between 1 and 21.
7.
7. Okay, let's look at 7. Determine whether the following equation represents y as a function of x. Okay. So now in this one, if we were to try to solve for y, right? So we could subtract x cubed from both sides. We'd have y to the 7 equals 27 minus x cubed. Again, if we have y to the power of 7, we would take the 7th root, right? So we only have to introduce plus or minus when it's an even root. So like if we did 4th root, 6th root, square root, 8th root, any of those, we would have to do plus or minus. But because this is an odd root, we don't have to do the plus or minus, so we don't have that thing going on. I think the domain is all roots, right? So because we're not taking an even root, it's going to pass the vertical line test, and the result here is going to be a yes, right? Before I submit that, let's look at the viewing example, right? And let's see what they say in the viewing example. So it's something similar. It says to determine whether this represents y as a function of x, solve the equation for y in terms of x. If 2 or more variables of y can be obtained for one given value of x, the equation is not a function. There are 2 parts remaining. So we solve, notice they have their 7th root, right? They took the 7th root of both sides. So because this equation is an odd Morehouse. Let me respond to this really quickly. So let me hit reply. And I'm going to CC Curtis Clark. Give me just a moment, gentlemen. The 14-day trial should be extended for another 14 days momentarily. If you, let's see, you should receive an email regarding this. I have also CC'd mathematics department chair. For on this email. If you have additional concerns. Cool. All right. So, all right. Yeah, so there was a student, that's a valid concern because, if it locks you guys out, then I understand you not having access and then that can affect your timing. So that's how I went on and responded to that, especially since I have a response to that thing. So, okay. All right. So right here again, because the seventh root is an odd nth root, there's exactly one corresponding y value for every x value in the domain. Therefore, this does represent y as a function, right? Long story short, if we had done an even root, again, like square root, fourth root, sixth root, eighth root, something like that, then we would have to introduce the plus or minus and it would fail the vertical line test. But because we're doing an odd root, it's going to pass the vertical line test, we'll be okay. All right. Again, that's not obvious. You wouldn't know something like that unless you maybe clicked on this view and example or as you made your way through the homework. That one is not obvious, right? So I'm glad we kind of got that, okay? So we're going to say, yes, this is a function. We're going to say, do the final check. If we can get it to work. Nice, okay? And so, with the sections today, we're going to give it approximately like 10 minutes a section. Let's do one more question from this section, then we'll go to section 1.2. And as always, if you have questions, feel free to either unmute yourself to get my attention or type in the chat. Matter of fact, let me check on Zoom really quick to see if we have any stragglers. We do. Let me get the student. I think it's just the one. And let me update my attendance. Got it, coach. Okay, so I'm only missing 2. It's not bad. Let's see. Yeah, we'd like to do one more from this section. What question do you think Google is going to give us? Which number do you think? Which number are you feeling? What does your intuition say? Just practicing, just being silly. Real quick. You can type it in the chat if you want to guess. Let's see. I'm going to guess 18. All right, that was a random number that I saw on the screen. I'm going to guess that it's going to choose 18. Hey, Google, give me a random number between 1 and 21. I see 7.
18.
Oh, that's 2 for 2. That's the second one that I've gotten today. I got one earlier. I was like, okay, my senses are sharpening. They're heightening. I'm getting my sixth sense, like Charles Xavier, Professor Charles. Look at that. Well, I forgot what number I chose. It was like 18, I think it was. So, okay. Now, see, the real question is, did I feel the number coming or did they choose that number because I put something out into some energy out into them? Like, if you start getting into like those subtle energies and, studying that scientifically, man, it gets trippy. It's like, like with like the quantum realm and like quantum mechanics and physics and stuff like that. Like when you start getting into those smaller realms, that's why I really appreciated Ant-Man, because like they kind of, it wasn't too scientific or anything, but when you start to get into those quantum realms, the rules of physics as we know it like don't hold. And like I know there's one theoretical physicist. His name is like Gates or something like that. And like I remember he came to Morehouse once, and I got to meet him. He had his gray hair slicked back, in a poof, and it's really trippy when you start to study it because his research was showing that like when you get down to the minute scale, like beyond molecules and atoms and subatomic particles and quarks and whatever some of the new particles that they found, he was like, it was basically reality was like behaving like ones and zeros. He found all these indicators where they were basically like ones and zeros, like computer code. So for us, we think it's reality, but when you study it, it's almost like computer code. And so there's this ongoing narrative that a lot of scientists feel that like we could be living in a simulation, right? The simulation theory, where the idea is that, if you think of the game Sims, right? Where, we think we're in quote unquote base reality. And then so in this reality, we start making simulations, right? So we make this game Sims. It's supposed to be a simulated version of the reality as we know it. So now you have these beings that live inside the Sims reality, but they don't know they're in a simulator. And so eventually it gets to a point where those inhabitants inside that simulator start making their own simulations. So now you have simulations within simulations. And then you can keep, over time, it'll keep getting more and more nested simulations. And so there's some merit to this because, when we got technology about 40 years ago, give or take, video games would be something like Pong, where it's basically these bars and you're trying to stop this ball. It's like table tennis, but it's called Pong. And then you fast forward to today, and the simulators are like hyper realistic, where it's nearly indistinguishable from reality. Like the graphics are so detailed, and the technology has advanced greatly, and it's only been like less than 100 years, give or take. So if we can advance this rapidly in less than 100 years, who's to say that there's not an advanced civilization that's thousands or millions of years older than us that's already created simulation? You know what I'm saying? Like, so we can make quote unquote advanced simulators right now. How do we know that there is an advanced civilization that's already made an advanced simulator? And how do we know we're not in that simulator, right? So the way that simulation theory goes, if you were to take base reality along with all of those nested simulator realities, if you put all of those out like side by side or whatever, and you take a dark and you just randomly choose one of those, either between base reality versus the nested simulators, the chances of you landing in base reality is practically zero. So because the chances are so low of us actually being in base reality, that means, or that implies, that there's a high probability that we might actually be in a simulator. And then you get people like, Dr. Gates or whatever, studying the subatomic particles or the subatomic, the quantum realm or whatever. And he's finding these Enigma symbols that are behaving like ones and zeros everywhere. He's like, wait a minute, we might actually be in a simulator. So as like time progresses, there's more and more evidence that we might actually be in a simulator. There was another thing I wanted to bring up regarding that. Give me just a moment. So there's a series on Netflix. I don't know if you've seen a series on Netflix called Black Mirror, but their latest season, they actually touched on the simulation theory. I was like, Black Theory is trippy. If you're not ready for your mind to be warped, don't watch Black Mirror. But if you kind of, if you feel like you're ready for it, take some time and go through. I think it's about 6 seasons in Black Mirror. It's trippy. Now that first episode is a little bit, I try to encourage people to watch 2 or 3 episodes beyond that. But yeah, Black Mirror is good. Like, it's trippy. And it's accurate, like, with some of the concepts, Let me get back on task. That's my favorite thing to do, is just go on these little tangents. That's why I love to live stream. So at least it's a copy of it somewhere in the cloud. And I could always, like, I figure one day somebody's going to hear these conversations, even if, whatever. I just think it's interesting. So that was a little bit about like simulation theory, string theory, that kind of stuff, right? And just fun stuff and intuition. But yeah, I got it right. So let's look at 18. So bringing it back on home. So we're asked to use the graph to find the indicated value of the function, right? So we have this image. It's a diagonal line with a negative slope. It looks like it passes through the origin. It looks like it has a slope of, is down 1, and right 4 looks like it has a slope of -1/4. So they're asking us to find the corresponding y when x is -4. So when x is -4, it looks like the corresponding y is +1. +1. Let's go +1. Okay, right here. Are you going to work for me? All right, let's try 1. Nice. Hit enter. All right. Again, if anything is not clear, feel free to either unmute yourself to get my attention or type in the chat. I am monitoring the chat. Let me check my attendance one more time to see if I have any. Yes. Let me let the student in. Give me just a moment. Right here, and let me update my attendance. Go ahead. You had a question. Is there a question somewhere going once?
Yeah, twice. Can you explain why?
So your audio I can barely hear you. Your audio is going in and out. You can either continue to try to use the audio or type it in the chat because I can't hear you. Like it was real like choppy and digital or whatever. Okay, let me see. Why is it one more time? Okay. So for instance, in this one, it says so the given x value is -4. So when we look at this graph, right? The origin is 0, 0. So when x is -4, if we trace left, starting from the origin, 1, 2, 3, 4 to the left, then the corresponding y is a 1, right? It's kind of hard to see. I need to be able to draw on it. Right, when x is -4, the corresponding y is 1 because that's where it crosses the graph. Right, -4 when it goes up and you go over to the right, the graph, the corresponding y is 1. Right, hopefully that makes sense. I can do a different presentation if it doesn't. Let's do a similar question. That was actually fairly quick. So for instance, if we look at this one, x is -1. So if we're looking at this graph, when x is -1, just in the chat, can you tell me what's the corresponding y? When x is -1, what's the corresponding y? Anybody see that one? Yeah, yes, right? Hopefully you guys can see that okay. When x is -1, the corresponding y, I would agree is 2, okay? So let's try a 2 here. Okay, hopefully that kind of got it to sink in. All right, let's move on. Let's move to section 1.2. Let's go here. Back, assignments, right? Let's go to section 1.2. All right, so let's see if we can sharpen our intuitive skills a little bit more, right? What number do you think Google is going to choose? I'm going to go with lucky number 13, right? What number do you think Google is going to choose, right? Okay. Hey, Google, give me a random number between 1 and 20. Didn't say it right. Let me do that again. Hang on.
Here's a random number, 1.
No, that doesn't count. Hey, Google, give me a random number between 1 and 22. I said 13.
Here's a random number, 5.
5. She's been saying 5 all day. It was like 5 and 15 or once she kind of keeps repeating. So apparently humans cannot generate a random sequence. Like if you try to generate a random sequence, when you go to test it to see if your numbers are actually random, it can be shown that the numbers are not necessarily random. We tend to create patterns and tend to be repetitive, right? No matter how much, like that's an actual topic in mathematics. Given a string of numbers, how random is it? Is it normally distributed? Is there a Poisson? Like what type of distribution is it displaying? Is it uniform? And like as humans, if we try to generate random numbers, there's a test that can show like, hey, these numbers are not random. But anyway, so in this example, we're asked, find an equation in slope-intercept form of the line that passes through the given point as the slope m. Also, sketch the graph of the line by locating the second point with the rise and the round method. Okay. Equation of the slope-intercept. So slope-intercept is basically talking about y equals mx plus b. All right, so they gave us the slope. Only thing we're missing is the y-intercept. I should write this down. I am totally being a little bit lazy. Let me turn this off. I'm going to try to take my notes here, but I should write it out, right? If I wanted to be proper. So if we're doing here, I'll take my notes. So we're going to say y equals mx plus b. So they gave us the -7/6. And they also gave us an ordered pair. When x is 6, okay, we don't know the y-intercept. The corresponding y is 3, right? So essentially what we have is one equation, one unknown we can solve. Obviously, I should be writing this out. We have -7/6 times 6 plus b equals 3. So then we have one equation, one unknown we can solve. If we go to do calculations, notice we have a 6 on top and a 6 on bottom. They're going to cancel each other. Then we're going to have -7 plus b equals 3. So we add 7 to both sides. Long story short, we're going to get b equals 10, right? So we got our y-intercept is 10, and we were given the slope. Once we have the y-intercept and the slope, we can just plug it in. So we got a y-intercept of 10, so I'm gonna just change it here. I'm gonna change this to 10. And our slope that was given was a negative 7/6. I'm gonna get rid of this other stuff. Again, I was just being a little bit lazy and taking my notes here, all right? We plugged in the given x and the given y and the given slope into y equals mx plus b. We solved for b, and we got a b of 10, and then we plugged in our b and the given slope to get this. Okay, let's check this. Okay, and then we're asked to graph. So the y-intercept is 10. Okay, sit, lay down, sit. Please stop pacing. You drive me nuts. It's not confusing. It's not a head scratcher. Go sit down. Get down. Come here. Sit. Right here. Sit. Okay, that's good. If you want to lay on the concrete, you can lay on the concrete. Thank you. Just chill. All right. Now, sit down. Thank you. Yeah, I know you got to go. Just give me like 10 minutes. Can I get 10 minutes? Are you looking at me with them sad puppy dog eyes? Okay. So sit. Come here. Sit. So we got a y-intercept to 10. So we're gonna basically plot a diagonal line. What I'm gonna do, I chose my line tool. Come here. Sit. Sit down. I'm just gonna plot two random points, right? I'm just clicking randomly. Sit. Every time I like take my attention away from her, she has like, I'm trying to get her, she has like no short-term memory. Come here, like Dory. She's so silly. Stop. Thanks. Just sit down. I know you gotta go. We about to go outside. You can sit on the pillow. Whatever. Okay. So now to this graph as it is right now is not correct. So what we're gonna do, we're gonna drag these points to the proper location. And as soon as I take my attention away, she just goes wandering again. It's so like, so we said we had a y-intercept to 10, okay? And then we can use the slope to get to a second point. So the slope is a -7, a rise of -7 and a run of 6. So that means our y value is gonna be 3 and our x value is gonna be 6. All right. So we went down 7 and right 3. So we should be at the point, down 7 and right 6. So we should be at the point 6 coming through. I think this looks good. Notice we have a negative slope of -7/6. We have a y-intercept of 10. So I'm going to hit save and I'm going to check this result. Okay. So let's do one more here in this section, and then we'll use the remainder of the time from section 1.1. Okay. I am going to go with 17. I'm thinking it's going to give me 17. Okay, let's see. Let's see. Hey, Google, give me a random number between 1 and 22.
Here's a random number, 11.
11. 11, angel number. Okay. Let's go with 11. Find the equation of the line that contains the given point and is parallel to the given line. Write the equation in slope-intercept form if possible. Okay. So whenever we see parallel, perpendicular, or neither, that's really a discussion about slope. Can anybody in the chat explain to me when lines are parallel, what does that mean about their slopes? Or when lines are perpendicular, what does that mean about their slopes? Right? What does that mean? So parallel lines have the same slope. There it is. There it is. You said it just as I was saying it. That's awesome, right? So parallel lines slopes are the same. Perpendicular lines, their slopes are negative reciprocal of each other. In other words, when the first slope times the second slope, when we say slope 1 times slope 2, if our answer is -1, then the lines are perpendicular, right? The lines are perpendicular. So parallel means they have the same slope. Perpendicular means the slopes are negative reciprocal. For instance, the negative reciprocal of 2 is a negative 1/2. The negative reciprocal of negative 7/6 is a positive 6/7, right? So if we want parallel lines, ours needs to have the same slope. Now notice, they gave us a line where it says y equals -5, right? So that, notice, y equals -5 is a horizontal line through y equals -5. That has a slope of 0. So that means our line, if it's going to be parallel, also is going to have a slope of 0, which means we're going to be working with the horizontal line. And horizontal lines take on the form y equals some number, right? So if we want a horizontal line through the given point, then it's just going to be the y coordinate of that point. So the equation of the line is going to be y equals 5. Hopefully you're able to keep up with that. I know that was a little bit much, right? Let's use the remaining time to work on section 1.1. My dog is still pacing. Come here. Come here. Sit down. Sit down. Here. You can sit on the thing. Yeah, so you're not directly on the concrete. We're about to go outside. Can you give me just less than 10 minutes? Just can you sit and just relax for 10 minutes and then I'll let you out. Please, with some sugar on top. Thank you. Okay, let's go back to assignments. Come on. Let's reload. And let's do a few questions from section 1.1. Continue. Okay. Let's see. I'm going to guess number 14. All right. I'm going to say that Google's going to choose. We're going to work on question 14. What question do you think Google is going to choose? What do you think? Okay. Let's see. Hey, Google, give me a random number between 1 and 20. I see your question. I'm coming.
Here's a random number, 13.
Ooh, close. I said 14, she said 13. And I usually choose 13. Let me open up this, and we have a question that says, is perpendicular, because it's the opposite of y. So perpendicular, lines that are perpendicular means that they're negative reciprocal, right? The slopes are negative reciprocals of each other. Now, the example that we just did, they were parallel because, they said that they wanted to be parallel. For instance, the negative reciprocal of 2 is a negative 1/2. The negative reciprocal of like -3 is a positive 1/3. You flip the sign and you flip the fraction. Another way you can visualize or articulate perpendicular lines, if you say slope 1 times slope 2, if your answer is -1, then the lines are perpendicular. Okay. So we're working on 13 here. It says, test the equation for symmetry with respect to the x, the y, and the origin. Okay. So I know we didn't talk about this live, but this should be in my pre-recorded lecture. So when it comes to lines of symmetry, right? Lines of symmetry. If a graph has y-axis symmetry, that means that if you were looking at the picture, if you were to take the image and fold it along the y-axis, the two halves are going to match up. So y-axis symmetry means you can fold along the y-axis and they're going to match up. X-axis symmetry in a pictorial representation means if you fold along the x-axis, the two halves match up. And origin symmetry means, I like to call it rotational symmetry. If you cut along the x-axis, put your thumb on the origin, and if you take the top half and rotate it 180 degrees, so it's upside down, the top half is going to be a match to the bottom half with that procedure. Another way to articulate that is whenever you have x comma y, you also have negative x comma negative y, right? So this is the pictorial representation. Algebraically, to show for symmetry, if we want to show y-axis symmetry, we change x to negative x, we simplify. If we get back to the original, then we can say y-axis symmetry. If we want to do a test for x-axis symmetry, we change y to negative y. We simplify. If we get back to the original, then we can say x-axis symmetry. If we want to do a test for origin symmetry, this is going to be the last one for the day. If we want to do a test for origin symmetry, we change both. We change x to negative x, and we change y to negative y and simplify. If we get back to the original, then we say origin symmetry. And one final piece of information there is whenever you have two of those to be true, like between y-axis symmetry, x-axis symmetry, and origin symmetry, whenever two of those are true, you're guaranteed to have the third one to be true as well, right? Okay, so with that, let's take some time. I'll take some time. I'm going to go ahead and get a screenshot of this and write this one out. And this is going to be our last one for today because we're pretty much out of time. And I get a 2-hour break before my next group. I know I'll be going hard on Monday and Wednesdays. And also, if you join us late, so Monday's a holiday, so we're not gonna meet Monday. Your exam one will become available this upcoming Sunday, right? And you can earn max credit for 7 days. I'm gonna copy and delete this. So this is our first one. This is the only one that we wrote out today. Let's paste here. Nice. Thank you for working. Because sometimes you be throwing tantrums. You are awesome. You gotta talk nice to your technology, right? Because if you call it stupid and all this other stuff, the technology is gonna be like, your wish is my command, and then it's gonna stop working. But it's not that it doesn't work when you're gentle with it, but when you're energetically gentle with it, it tends to respond to your energy or whatever. It tends to behave like that. Okay, so let's do the first one. If we want to do a test for, there we go. If we want to do a test for x-axis symmetry, did the pin die? He did. You're charged. Let me see. Come on. Oh, you look good. All right. Okay. So if we want to do a test for x-axis symmetry, you are definitely lagging though. What we do is we change y to negative y, and then we simplify, right? Okay. So here we would have what? Negative y equals 2x to the power of 6 plus 7x squared, right? So is there a manipulation that we can do to get back to the original? For instance, if we try multiplying by a negative, we won't get back to the original. So long story short, is there x-axis symmetry? We're going to say none. There is no x-axis symmetry, okay? If we want to test for y-axis symmetry, what we do is change x to negative x, and then we simplify, right? So because one of them failed, that means all three should not work, but we're going to keep going to see if we can get one of them to work, okay? So if we change x to negative x, and we're going to simplify. So we have y equals 2 times negative x to the power of 6 plus 7 times negative x squared, right? If we notice that if we raise a negative number to an even power, give me just a moment. I see the time. Give me just a moment. Come on, quick. Whew. Okay, I'm just trying to wrap this up. That's okay. I'm not gonna worry about that. Well, let me join. Didn't realize it was gonna boot me off. Don't connect or not. Join. Just trying to get. I'm trying to get you guys out of here. Stay as a participant. Okay. So notice if we raise a negative to an even power, then it becomes positive, right? If we have an even number of negatives multiplied, it becomes positive. So this is going to be the same as y equals 2x to the 6 plus 7x squared, right? Which is the original. So this is a yes, right? We have y-axis symmetry. And instead of none, I'm going to change that to no, right? Okay, so we do have y-axis, so we should not have origin, because if we had origin, then we would have to have the x-axis symmetry as well, right? So this should be the only one that we would have here. Can't have two without the third in this case. Okay, so we should only have y-axis symmetry. So let me hop back over here. Is there x-axis symmetry? We're going to say no. Submit. Okay. Is there y-axis symmetry? We're going to say yes and submit. Okay, and then is there origin symmetry? Again, we're going to say no because, you know, if you have two, you're guaranteed the third. Since we don't have the first and we do have the second, that means we should not have the third, right? Okay, so that brings us to the end of today. Are there any burning questions before we go our separate ways? Okay, well, you guys, I'll pause for a moment where you want to think about that. Let me go ahead and make a copy of this available. I think it was just the one, but let me share. I'm going to send it a box. I think that's the right location, so I'm going to send it. When this bar finishes loading, you'll receive a copy of anything that we wrote together in this context. Last call for alcohol. Are there any burning questions before we go our separate ways? Other announcements. So you can anticipate exam 1 to become available this Sunday at 11:11 a.m. For the first 7 days, you can earn full credit. Like you can earn up to 100%. You get unlimited attempts. The system is set to take your highest score, but past the due date, which is basically the following Sunday, any questions submitted past the due date, there's a 10% late penalty. So the highest you can earn on any question submitted late is 90%. Unlimited attempts, the system is set to take your highest score, okay? Monday's a holiday, so we're not going to meet on Monday. We're going to meet back here, same time, same place on a week from today, which is Wednesday, okay? Also, be on the lookout if you should be able to get an additional 14-day extension on the homework. You should have received the email. If that stuff is missing or whatever, then I would encourage you to reach out to either the mathematics department chair or the bookstore. I think those are the two. It should be one of those two sources should be able to help you with that. But again, there should be an additional 14-day extension for everybody that's using it, okay? All right. So if there aren't any other burning questions, we're going to end the session here. From one beautiful mind to another, happy holidays, have a great weekend, and I'll see you in 7 days, same time, same place. Take care, guys. Peace. Hey, Google, play some non-copywritten cafe music.
Sure. Here's a YouTube music playlist called Background Music. No copyright. Speak no evil.
A little bit slow. Should have had that like unlocked already. Hit play. Okay, that sounds cool. All right, guys, take care. Hey. Yeah. I'm feeling this. Don't relax. Nope, not feeling that. Take care, guys. Peace. Let me see the chat real quick. I think the chat is good. Yeah, we're good there.